Okay, YouTube, in this video we're going to explore how we can use nth roots to solve equations. That is, equations of the form u to the nth power equals d, where u is some algebraic expression. But when we have equations of the form u to the n equals d, our primary method for solving these will just be to get the base that is being raised to this power of n by itself on one side, and once we do that, we'll just take the nth root of both sides. So we've solved using square roots before. This is more general, and we're saying, well, what is the nth root of u to the n? Well, what you get is just u, because recall that the nth root of u to the n would be the number that when we take it times itself n times, we get, u to the n. So we get u. U is that number I took to the nth power to get, u to the n. So we'd say u. On the right side, we just get the nth root of d. And because I know some techniques for evaluating these expressions now, we can come up with a decimal if necessary, or just get an exact value if we're desiring that. So let's go ahead and take a look at a couple of equations here that we can use this nth root technique with. So we say 5x to the third is equal to 320. I'll write this down here. So 5x to the third is equal to 320. And so number one here, we're going to isolate the base of the power, okay? Base of the power. So what this means is the 3 here only applies to this x. So that means we need to get rid of this 5. Dividing both sides by 5, what we end up with is this x cubed, and on the right side here, I suppose we would get 20, 20, and then 4, so 64. And so we would say that now that I've isolated this, we're going to take the nth root of both sides. Now I'm going to write simplify if necessary, because we're going to need to simplify when necessary. So taking a look at this equation here, we take the nth root of both sides. In this case, we need the cubed root of both sides. So what could I take times itself 3 times to get x to the third power? Well, I just take x. In other words, when you take the nth root of anything to the nth power, you're just going to get that thing. And over here we say the cube root of 64. Well, the cube root of 64 is just a positive form. So we say that this right here would be our solution of this equation. And it'd be really easy to go back and check. If we go plug this in, we could say that 5 times something cubed is equal to 320. And if we put in a 4 right here, we get 5 times 64 equals 320, which is 320 is 320. So now taking a look at this next example, we have x plus 3 to the fourth equals 24. And what I just really want to highlight in red here is that this right here, this is all being taken to the fourth power. So this is the base of that fourth power. And since we already have the base of the power isolated, then what we're going to do is this. We're going to go ahead and take the nth root of both sides. And in this case, we're going to take the fourth root of both sides to get rid of this fourth power. So on the left side, we get left with just x plus 3. And on the right side, we get this fourth root of 24. Now, in terms of fourth roots, I know that 24, if I break this down as 2 times 12, which is the same thing as 2 times 6, which is the same thing as 2 times 3. In other words, 24 is 2 to the third power times 3 to the first power. And since we're taking a fourth root, we can't extract anything out of this. We're really just going to end up with this. We're going to get the fourth root of 24, and it's plus or minus. And so now the last step we need to take here is just to go ahead and subtract 3 from both sides. These will cancel, and what we get left with is x is equal to negative 3. Instead of plus or minus the square root of 24, we just get plus or minus the fourth root of 24. And these would be our solutions right here to these equations. So that's how we can use this property of nth roots to solve an equation when we can rewrite it in this form u to the nth power equals d. Cheers.